Hi there, this is a presentation that I gave at the Docker meetup in Melbourne on the 19th of January 2016. It's about using Docker for more flexible Jenkins. So, who am I? My name is Arjen Swartz and I'm Dutch. I worked in the Netherlands at a traditional hosting company, and then at some point I decided to go traveling. Now, about 3.5 years ago, I ended up in Melbourne, and I liked this place so much that I decided to stay. Now, for the interesting bit. For most of those 3.5 years, I worked at a web agency here in Melbourne, building web applications for clients. Now, web applications have gotten a lot more complex over the years. Not only is it the backend language anymore, can be different languages with their own versions and dependencies, stuff like that, but also on the front end side with the introduction of build tools like Grunt or Gulp, or even full-fledged frameworks like Ember and Angular. There's a lot more possibilities there, and of course developers want to take advantage of those things. However, we also need to be able to deploy them, to test them. For that, we usually use continuous integration systems. Now, in this talk, I'll be using Jenkins as an example, but there's nothing really specific here to Jenkins that you can't adapt to another platform. Now, the issue with a platform like Jenkins is that it's hard to have multiple versions of programming languages or operating systems on a single server. So, usually, a common way to solve that with Jenkins is to have a master server and then have different slaves with their own versions of the programming language, in this example PHP, installed on them. And then you can tell the projects to only run on a specific slave. Now, that's nice, but it leads to problems like this, where a big portion of your hardware or virtual server goes unused, while others will have a queue built up. And of course, it's not just limited to PHP either. You might have conflicting dependencies for other things like Gulp and Grunt, or, well, just name it. So in the end, that basically leads to a dependency nightmare where you have to keep different servers all in check one way or another, and that makes it all annoying. So I was thinking, how do I solve this? Now, obviously, as this is a Docker meetup, I found Docker as Now, obviously, as this is a Docker meetup, guess what I came up with? Now, Docker is of course meant to abstract the hardware it runs on, so you don't have to care about that and just have it all into your Docker container, which sounds a lot like exactly what I needed here. Except normally, or the regular way of running Docker with projects is that you have a Dockerfile for each separate project. This Dockerfile then contains everything you need, all the dependencies, everything, and you can basically run the project inside it. Now, we couldn't use this. First of all, we couldn't run the projects on production inside the Docker container. Not only did we not always have enough control over the hardware it would have to run on, the servers, but even if we had, we would need to convince each of our clients that running on Docker was worth it. And at the time we did not think it was stable enough, tested enough in production yet, so that was also a good reason not. However, the main reason is more that at a web agency you generally have a lot of projects, and building specific Docker files, Docker containers for each of those projects would have been a lot more work than would be worth it, especially as it means building them for projects that we're not currently getting paid for, So that was not the way to do it. However, we still wanted to use Docker for this. Now, I was thinking Docker is basically for task-specific containers. So if we just focus on that, look at the task-specific part, and then we remember basically CI tools are just like task runners. That means how about we just build specific containers for running those tasks? So for lint checks and unit tests, we would have a PHP container running npm install and cron build. For the front-end pipeline, would be using a node container. That way we wouldn't need to build as many containers. Still have a lot of flexibility and solve the issues I mentioned earlier. Because we would still need to build a number of containers. One for each PHP version, an Ember CLI, an npm version with grunt, one with gulp, because you can't really run those two together on the same container. That gave some issues. A MySQL, a Go, anything you want. So let me give an example. This example is an existing site. It's a legacy site running PHP 5.3 on load balance servers that are managed by the client. Now, a big part of the site was replaced with a nice new Ember application. So if we put this through the CI process as I just explained it, how would it go? Well, things like the lint checks, the PHP units, all of those, you would run on a PHP 5.3 container. But style checks and other things that where the PHP version matters less, we could run on PHP 5.6, for example. The same goes then for the Ember build. For that, we would use an Ember container. And if we wanted to future-proof it, we could do the lint checks and PHP unit and things like that. We could run them on PHP 7 as well, just in case the client decides to upgrade the servers. So, enough about the theory. How does this actually work in practice? Well, Jenkins, in case you're not familiar with it, uses end build files to run its tasks. A build file is basically an XML file with, as you can see here, some commands in it. Now, doing this for like cron build is very simple. If everything is in the server, like that. If we want it on Docker, it becomes a little bit more work. Still, it is basically just a normal Docker run command split up over different arguments. So you mount the volume, you tell it which container to use, and then you run a bash command to do cron build. Now, the Docker files themselves though, how do they work? How do they look? They are quite simple. In this case, for PHP 5.5, we base it on Ubuntu 14.04. This is simply done to ensure that the Docker container matches as closely as possible the actual production environment the application will run on, as most of those will be on Ubuntu 14.04. Then of course it's the normal apt-get install of all the dependencies, and if we then look on, see we'll need to install or provide the container with some private keys. We need to set up a known host file that knows about Bitbucket, GitHub, all that stuff. And additionally for Composer, which is basically PHP's dependency manager, we will need to provide some GitHub authentication keys as well. NPM instead we can base on Debian Jessie, just because it's lighter, smaller, and that makes it a little bit easier to work with. Again, the normal cat stuff. And then we install Node.js. We just pull it in, set all the settings. The next part though is another one of those little annoyances that sometimes crop up when you're working on something. Node needs the locales to be configured correctly, and so basically this is a combination of all the different ways I could find to fix that. It's possible that not all of this is needed, but this combination works. So I decided not to touch it anymore. And last, but definitely not least, we then install all the remaining things, including an update for npm. Another advantage of setting it up like this is that you can run it locally as well. Just as easy, because it's just a build file, it's an end file. You can just run the same command as Jenkins would run, and it all runs on your local machine. So it will be like this. Here you can see for Composer and the actual installation of the vendors. It uses the PHP 5.6 containers, which you can't really see because it's all transparent, but believe me, it does. Once it then goes to npm, it uses that container. Npm install, by the way, takes ages when you're doing it on a Mac using Docker because of the way the file system has to be mounted. So I would recommend not doing that. Just install that locally, and then this will go faster. And then of course bow install, and it would continue on like this. So a big advantage though is that you can have all your projects on a single server, regardless of what the dependencies are, what they need. You can just run it on one server. You can still use slaves if you want to, but you don't need them anymore for dependency issues. It's really now a performance reason, which is a much better situation. And the server itself is easy as well, as it only requires Jenkins and obviously Docker to be installed. So, but then you might be thinking, okay, that's nice and all, but how about if we want something a bit more complex? If we need our applications have interactions, how do we deal with that if they're all standalone? Well, the solution for that is also in the Docker realm. It's Docker Compose. Docker Compose allows you to link multiple containers together, and it then allows you to run a command when it's started up. In this case, we run composer install on a PHP 5.6 container while it is linked to MySQL so that it can do things that it needs to do there. The build XML file for that is also pretty straightforward. You just run Docker Compose, tell it which file to use, which means you can also have multiple files, and then just run up. A no color is of course just a preference, but it makes the output in Jenkins look better. Now, everything comes with downsides. Nothing is perfect. I've already mentioned some gotchas that I ran into before, but there are more. The main one of these is probably that everything is root. It's not a major issue. I mean, as in the way that you can work around it quite easily, but it is something to keep in mind. Mostly because when files are generated through Docker, these will be owned by root on the underlying file system as well, which means Jenkins can't touch them. So to solve that, you will need to add a little command or task to clean that up and make sure everything is owned by Jenkins. You can just do this through Docker container as well, so it's quite easy. Additionally, a lot of tools like npm or bower and grunt, they rightfully don't enjoy the fact if you're running as root. So you often need to provide some flags or parameters to ensure that they can run. Otherwise they'll just complain and say, oh, I can't do this. Now, sometimes, especially with legacy code, it is possible that you have parts of the task that you want to run on your CI system that don't really fit within a certain bucket. So a PHP task that also generates assets, for example, it will need a lot more things installed, like npm, Ruby, a whole bunch of stuff. You can basically deal with these situations two ways. One is build a complex Dockerfile just for that one purpose. That's always a possibility. Or two, fix the code. Neither solution is great, and you'll have to see what works best for you in that case. Lastly is maintenance. While of course, as I mentioned, there's a lot less maintenance, there's still some. You need to keep your Docker containers up to date, and especially when you have multiple slaves running, you'll have to make sure that all of those slaves run the same versions of the containers. And last but not least, of course, and not really an issue, but check if it really matches your workflow. If you only have a single project or a couple of projects, this might not be the solution for you. I would still recommend using Docker, but maybe instead of using different task containers, just have the regular Dockerfile per project. And that's it. Thank you for watching. If you want to see or read more from me, go to my site and ignore me. Otherwise, you can be reached on Twitter, and you can find my work on GitHub. Thank you very much.